Hi friends, this is Dr. P. Munaswamy, Professor, Department of ECE. Today we are going to discuss about the vestigial sideband modulation, introduction in time domain as well as the frequency domain description. So what is the need of the VSB modulation? What are the applications, advantages, disadvantages? So representation of the VSB, vestigial sideband modulated waves in time as well as the frequency domain. So what is the need of this one is, here already we have discussed about the various modulation under the AM, amplitude modulation. So amplitude modulation with full carrier, DS-based wave, that is double sideband, suppressed carrier. Here we are suppressing carrier signal and transmitting the only two sidebands. Another one is SSB modulation. Here we are suppressing the carrier signal and also one of the sideband. So in case of the DS-based wave, there are two sidebands, upper sideband as well as the lower sideband. So among these two are symmetrical each other. So by the properties of symmetry, we can retrieve the one of the sideband with the help of the other sideband. So that is the basic advantage in case of the SSB modulation. Even though we are transmitting the one sideband, with the help of the transmitted sideband, we can retrieve the other sideband by the property known as symmetry. So that is the SSB. Whereas coming to the VSB, vestigial sideband modulation techniques. So here we are transmitting the one complete sideband. Along with one complete sideband, we are transmitting a partial part of the other sideband. Why? Because so in case of the SSB modulation, so we are unable to generate the exact frequency range of the any one of the sideband. It may be upper sideband or lower sideband. So here, based on the frequency band, practically we are unable to generate the exact frequency. So because of this one, so what are the components or electrical components used for a reconstruction of the or regeneration of the carrier signal or modulating signal? We are using the electrical component like resistor, inductor, capacitors, which can decide the frequency of the carrier. So these the components, we are unable to get the exact frequency because of there is a tolerance value of these components. At the same time, the effect of the capacitance or inductance or resistance may be varies with the effect of the temperature from the outside or internal circuit. Because of these two reasons, so tolerance effect of the components, at the same time temperature from the circuit or outside can affect the generation of the exact frequency of the carrier signal. So because of the unable to generate the exact frequency range of the sideband, there may be a chance of losing the information. So we are transmitting only one sideband. So because of this frequency generation is not possible exactly, so there may be a chance of losing the information. So because of this one, this drawback which is available in the SSB modulation, you can go for the VSB modulation. So VSB is vestigial sideband suppressor carrier. It is also abbreviated as VSB-SC, vestigial sideband suppressor carrier. You can see the diagram. So you can transmit the one of the sideband, that may be complete sideband. Along with the complete one sideband, it may be upper sideband, lower sideband. We can also transmit a part of other sideband. Can you see the diagram? This is completely one complete sideband, VSB, upper sideband. So along with this upper sideband, you can transmit the other part of the sideband, that is LSB, lower sideband. So in case of the VSB modulation techniques, we are transmitting the one complete sideband plus a partial part of the other sideband. So automatically So by the arrangement of these components, electrical components for generation of the carrier or other sideband frequencies, so there may be a loss of the information from the other part. You can get the complete part of the one sideband. So that is the main advantage. Even though there is a loss due to the exact frequency generation, not possible. So because of the transmitting the part of the other sideband, you can easily obtain the one complete sideband in case of the receiver side. While retrieving the information signal at the receiver side, with the help of this modulated transmitted signal which consists of the one complete sideband along with the part of the other sideband, so that you can easily retrieve the other sideband. You can see the diagram here. So which is the combination of the one complete sideband. For this case, we are taking the VSB upper sideband, and other one is a part of the other sideband, that is LSB. So we are taking a part of the LSB and complete USB, then it is transmitted. So that is the vestigial. Vestige stands for a part of, meaning a general meaning of the vestige, a part of. So that we are taking a part of the one sideband and complete another sideband. So that we are transmitting this one. So then coming to the time domain representation of the signal. So here in case of the representing the standard wave equation SSB or VSB or DSB or AM signal in terms of the time domain only. So that is the S of t indication of signal in time domain. So S1 of t cos 2 pi ft, SQ of t cos 2 pi ft. These are all the represented in terms of the frequency domain, time domain. So whereas after application of the Fourier transform to the time domain equation S of t, we can convert this time domain equation into the frequency domain. So that is the main the transformation of the time domain signal into the frequency domain by the help of the Fourier transform. So that means we are going to analyze the entire equations of the VSB or SSB, DSB or AM signal. We are analyzing these standard signals, input signals in time domain as well as the frequency domain. So time domain means in terms of the equation will be in time S of t or M of t, or you take the C of t. These are the carrier signal. We are going to have the time domain. So once you have the operation of the frequency domain, you can have this Fourier transform function. You can convert this time domain signal into the frequency domain. So this is the mathematical equation for the frequency domain. So that is spectrum nothing but conversion of the standard time domain signal S of t into the frequency domain. We are going to have the S of f. So after the application of the Fourier transform, you can have the equation of 1 by 2 AC cos m of f minus fc plus m of f plus fc h of s. H of t can be, it is a transfer function of the filters, smoothing filter. So by the combination of both modulated wave on complete sideband along with the partial part of the other sideband, so you can smoothen with the help of this transfer function of the filter, smooth filter. So that means it allows the one complete sideband along with a part of the other sideband. So taking this complete, this one 1 by 2 AC m of f into h of f minus f plus h of f plus fc is the standard equation for our smoothing filter. So finally we are going to have the equation for the VSB-SC wave 1 by 2 AC m of f. So with the help of this, we can see what is the difference between the time domain and frequency domain. So in case of the time domain, the equation will be in terms of the time domain only. S of t will give the time domain. So after application of Fourier transform, we are going to have the spectrum. So spectrum nothing but analyzing the signal in frequency domain. So in terms of the f only, frequency domain only. So that is the spectrum of the ESP signal. So this is about the time domain representation of the VSB, Vestigial Side band modulated wave in time domain as well as the frequency domain. So then coming to the bandwidth requirement of the VSB wave. So what is the bandwidth required for the VSBSC wave? So whereas in case of the AM modulation, the total bandwidth, that is the range of the frequency for the AM, that is full carrier, two sideband with full carrier is 2 FM only, which we have discussed in the previous classes. So that is overall bandwidth requirement equal to 2 FM only. So whereas coming to the DSBSC wave, here also we are going to have the bandwidth requirement of the DSBSC wave, that is double sideband suppressor carrier is 2 FM only, because we are transmitting the two sidebands here, so that the bandwidth requirement is also 2 FM only. So there is no difference between the AM modulated wave and DSBSC wave. So both cases, AM modulation and DSBSC wave are same. Why? Because we are transmitting for both cases two sidebands. In case of the AM modulation, we are transmitting the two sidebands as well as the carrier signal. Whereas coming to the DSBSC wave, we are suppressing carrier signal and transmitting only two sidebands. So that is the bandwidth requirement for the AM as well as the DSBSC wave is same. That is 2 FM only. Whereas coming to the SSB, here we are not transmitting both sidebands. One of the sideband is transmitting, so that the bandwidth requirement for the SSB wave is half to the AM or DSBSC wave. So in case of the AM DSBSC wave, we are transmitting the two sidebands, so that the requirement is 2 FM only. Two sidebands we are transmitting. Whereas SSB, we are transmitting only one sideband, so we will get the by 2. So only we are getting the FM, which is the highest frequency component of modulating signal. So FM is bandwidth requirement for the SSB modulated wave. So whereas coming to the bandwidth requirement for the VSBSC wave is, here we are transmitting the one complete sideband along with a part of the other sideband, because Vestigial stands for a part of the other sideband. So we are transmitting the one complete sideband. The bandwidth requirement for transmission of the one complete sideband is FM. Along with this complete sideband, we are transmitting the part of other sideband, that is the partial of the other sideband. So we will get it can be considered as FV. So total bandwidth for the SB wave is part of other sideband FV, Vestige, V stands for Vestige, and the one complete sideband requirement is FM. So overall FM plus FV is the bandwidth requirement for the case of VSB-SC wave. So SSB only FM. The difference between the SSB and VSB is the part of the other sideband transmitting, so that overall it is the FV plus FM only. So one complete sideband requirement FM and part of the other sideband is FE. So you are getting the FE plus FM only. So that is the bandwidth requirement for the VSBSC wave is FE plus FM only. So then coming to the advantages of the VSBSC wave. So the first one is the high efficiency. So compared to the AM, DSB, SSB is highly efficient. You can transmit the one complete sideband, other sideband, part of the other sideband. So there is no loss of information in case of the VSBSC wave. So that it is a highly efficient. You can retrieve the signal as 100% without any loss. So this modulation is highly efficient. Next one, reduction in bandwidth when compared to the AM and DSBSC wave. So how it will be reduced bandwidth? So in case of the AM DSBSC wave, we are transmitting the two sidebands. The total bandwidth requirement is 2 FM. So that whereas coming to the VSBSC wave, so we are transmitting with the help of the bandwidth is FM plus FV. One complete sideband band requirement FM and part of the other sideband FV. So we will get the FM plus FV will be less than this one 2 FM requirement. So overall FM plus FE is always less than the 2 FM, so that automatically with the the VSBSC wave, we are reducing the bandwidth requirement also. We are not transmitting the complete two sidebands, one complete sideband and part of the other sideband, so that it will be lesser than the compared to the DSBSC wave and AM signal. That is another advantage of the VSBSC wave. Then coming to the third one, filter design easy since high accuracy is not needed. So because we are transmitting the part of the other sideband, we are not need to design the exact frequency. So the carrier frequency FC plus FE. So there is a change in the range. So automatically the filter design is also become easy to design the exact frequency band of this VSBSC wave. Whereas in case of the SSB, so exact bandwidth is there for lower sideband or upper sideband. So there is a very difficult to design the filter function for the case of the SSB, whereas coming to the VSB, it is easy. So that is the filter design is easy for the VSB-SC wave. Then coming to the next one, the transmission of the low frequency components is possible without any difficulty. So here, not only high frequency, so low frequency components also is possible in case of the VSBSC wave. Whereas coming to the SSB or DSBSC wave or AM signal, so not possible, somewhat difficult to transmit the low frequency. So low frequency it is very close to the audio frequency range, 20 Hz to 20 kHz. So that in case of the DSBSC wave, AM signal and SSB, somewhat difficult to transmit the low frequency components. Whereas coming to the transmission of the low frequency components is easy without any problem by the help of this VSBSC wave. Then next coming to the process good phase characteristics. It consists of the good phase characteristics. So we are going to have the frequency and phase characteristics of any modulated wave. So whereas coming to the VSBSC wave, you can have the good characteristics in case of the VSBSC wave, whereas SSB and DSB and AM signal has not had a good phase characteristics. Only the VSBSC wave has the good characteristics. So these are the advantages of the VSBSC wave compared to the SSB or DSBSC wave AM signal. First one is the high efficiency, reduction in bandwidth, filter design easy, the transmission of low frequency component is possible, and possess the good phase characteristics compared to the SSB, VA, and DSB and the AM signals. So these are the advantages of the SSB, VSB. Then coming to what are the drawbacks of this VSBSC wave, Vestigial Side band suppressor carrier. So bandwidth is more when compared to the SSB. So only comparing with the SSB. So in case of the SSB modulation, we are transmitting only one sideband. So whereas coming to the VSBSC wave, we are transmitting the one sideband plus a part of the other sideband. So that the bandwidth requirement for the VSB is more than the SSB. That is only the drawback for the case of the VSBSC wave compared to the only SSB only, not AM and DSB. So comparing the AM and DSB, it is lesser bandwidth only. Whereas comparing with only SSB, it is a little bit, that is part of other sideband FE is more than the actual requirement of the SSB is FM. So bandwidth is more when compared to the SSB-SC wave only. Then coming to the second one, demultiplex, demodulation is complex. So coming to the retrieving side, receiver side. So finally we are going to receive the modulated wave, or that is the VSBSC wave. While coming to the regeneration of retrieving the original signal MFT, so that will be complex. Why? Because so here not exact related to the one sideband. It is a combination of the one sideband as well as the part of the other sideband FE, so that the design of the circuit at the receiver side for retrieving the original signal of MFT is difficult. So whereas AM signal and DSBC wave and SSB, comparing these and design of the demodulation circuits at the receiver side is somewhat easier compared to the this VSBSC wave, vestigial sideband suppressor carrier. So these are the two drawbacks for the VSBSC wave. So bandwidth requirement is little bit more than the SSB when compared to the SSB only. So because there is a FE, other part, a part of the other sideband will be more. Other one is a demodulation is complex. So little bit transmission bandwidth is adding for the modulated wave, that is FE, so that a receiver side, coming to the receiver side, the design of the circuit for retrieving the original signal M of t is somewhat difficult in case of the VSBSC wave. Then coming to the applications. So here the most prominent and standard application of VSBSC wave, transmission of the television signals. So coming to the transmission of the TV signals, there is a two signals we are going to transmit in case of the TV broadcasting. One is the audio signal along with the video signal. Picture signal is also transmitting along with the audio signal. So for the transmission of the audio signal, we are going to use the frequency modulation techniques, FM. We'll see the later what is the FM. And then coming to the transmission of the audio signal or video signal, that is done by this VSBSC wave only. So with the help of the VSBSC wave modulation, we can transmit the video signals, whereas coming to the audio signal is transmitted by the frequency modulated waves, FM. So these are the two modulations used for the transmission of the TV broadcasting, audio signal as well as the video signals. So these are the main applications of the VSBSC wave. So only this modulation is used for the TV broadcasting. We are not using the other transmission techniques. That is AM, DSBSC wave and SSB. We are using only VSB only. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.